Okay, today we're going to take rational expressions that contain binomials and reduce. All right, so let's recall. A binomial is a polynomial that has exactly two terms that are connected by addition or subtraction. Well, we're going to have a problem now, because remember, a rational expression is a fraction, and a fraction has a fraction bar, which means division, and in order to do division, you must be connected by what operation? That's right, multiplication. Binomials are not connected by multiplication, so we're not going to be able to take apart the different terms and divide them separately. What we're going to have to do here is look at the whole binomial as an entity and the whole binomial as an entity. So, look at my first example on our PowerPoint. A plus 6 divided by A plus 6. What you guys are going to jump in and try to do is say, all right, I'll divide A with A, get 1. I'll divide 6 with 6, get 1, and add it up and make 2. And that is incorrect, because you cannot even do division. Because to do division, your terms, your A and the 6, would have to be connected by multiplication, and they are not. So you can't separate the terms. You have to look at it as a whole entity. You have to look at the whole numerator as A plus 6 and the whole denominator as A plus 6. So you're going to see when I go to the whiteboard, I'm going to put that whole numerator in parentheses to say the A and the 6 are stuck together like glue. In the denominator, the A and the 6 are added. They're stuck together like glue. I can't take them apart. So now what I'm asking you to do is look at the numerator and look at the denominator and see if you see a pattern. In the numerator is A plus 6. In the denominator is A plus 6. What do you know about those binomials? That's right. They're exactly alike. Well, we know from arithmetic what happens when you divide the exact same number. Say 6 divided by 6. You get 1. Negative 7 divided by negative 7. You get 1. Well, if that's the rule in arithmetic, it's the rule in algebra. And we've already seen that. X divided by X is 1. So if it works for monomials, it also works for binomials. A plus 6 divided by A plus 6 will be the quotient 1. You're dividing the same binomial by the same binomial. If you look at my second expression, B minus 7 divided by negative 7 plus B. Now, when you first look at it, the numerator and denominator do not look alike. But if you look closely at the denominator, it's not written in the correct descending order. So if you took negative 7 plus B and wrote it correctly in descending order, it would be B minus 7. So in the numerator, you'll have a B minus 7. In the denominator, you'll have a B minus 7. Both of those binomials are exactly alike. And when you divide terms that are exactly alike, your answer is always 1. Now, what happens if your terms are additive inverses? For example, think about arithmetic. What is the additive inverse of 6? That's right, it's negative 6. Well, when you take 6 and divide it by negative 6, you get negative 1. What is the additive inverse of negative 7? Very good. It's positive 7. What happens when you divide a negative 7 by a positive 7? That's right, you get negative 1. So now we have another rule from arithmetic. When you divide terms that are additive inverses, opposites of each other, the quotient is always going to be negative 1. So let's look. I have A minus 6 and negative A plus 6. When I look at that expression, I see they're binomials. So I cannot separate the pieces. I cannot just do A divided by negative A and negative 6 divided by positive 6. That is wrong. You cannot separate the pieces, the terms. They're not connected by multiplication. So when I go to the whiteboard, I'm going to show you, I'm going to put that binomial in parentheses to say it's glued together. I'm going to put the binomial in parentheses to say it's glued together. Let's look closely. A in the numerator is positive. A in the denominator is negative. Those are additive inverses. 6 in the numerator is negative. 6 in the denominator is positive. Those terms are additive inverses. Therefore, A minus 6, the numerator, and negative A plus 6, the denominator, are truly additive inverses. They're opposites of each other. And when we divide opposites, our quotient is always going to be -1. Look at my last expression. B minus 7 divided by 7 minus B. Okay. What you'll look closely and say, those terms don't look the same. Again, we're looking for a relationship. Are the binomials the same or the binomials additive inverses? Well, they're not the same because the b in the numerator is positive and the b in the denominator is negative. So they're not the same. So we know the quotient here can't be 1. B and negative b are opposites of each other. Now, if we're additive inverses, that means all the terms in the numerator are truly the opposite of all the terms in the denominator. So now we got to look at the 7s. The 7 in the numerator is negative. The 7 in the denominator is positive. Those are additive inverses. So because the b's are opposites and the 7s are opposites, the whole expression is an additive inverse of each other. And when you divide additive inverses, your quotient is always -1. There's no work to do. These are just rules. So I'm training you to think about algebra like you do arithmetic. If you divide the same term, the answer is +1. If you divide additive inverses, your quotient's going to be -1. All right, let's go to the whiteboard and try a couple.